All right, the next kind of level of solving trigonometric equations is going to be around double angles, half angles, or what is called like compound angles, so like addition and subtraction. So if you look at this first equation here, notice that it's cosine of 2x equals 1/2. Now, one thing that students sometimes try to do is they try to kind of like undo this with division. Remember, this is a composite function. It's the cosine of 2x, not cosine times 2 times x. Whenever we have this like inside piece that's not just a theta, what I personally like to do is do a substitution and to say like, okay, let's say that theta is equal to 2x. If I do that replacement, then I want to know where on 0 to 2 pi, so where on one interval of my unit circle is cosine equal to positive 1/2. Well, cosine is positive in quadrant 1 and quadrant 4. And if I want cosine to be equal to 1/2, it has to be the taller 30, 60, 90 triangle. And so that's going to be at theta equals pi over 2. And at theta equals, let's see, this would be 3 pi over 3. I think I said pi over 2, sorry, 3 pi over 3. This is me 3 pi over 3, 4 pi over 3, and then 5 pi over 3. Now remember, that's theta, and that means I need to set that then equal to 2x to figure out what x would be equal to. So I'm going to divide by 2 and get that x is equal to pi over 6. Sorry, that's my dog. And then divide by 2 here and get 5 pi over 6. Now that may seem like we are done, but remember that this is, I know it's not on this interval, but I just want to make sure I have all solutions here. This is equal to plus 2 pi n if I go forever and ever and ever. And so if I say that's equal to 2x, and I divide by 2 here and by 2 here, then this would repeat every pi n. And if I add 1 pi, I need to also include here 7 pi over 6 in my domain that was given to me originally. Similarly here, when I divide by 2 and divide by 2, I have another pi, so I also need to include 11 pi over 6. Now let's think about rectangularly why this is the case. If we have cosine of 2x equals 1/2, then that means every pi I need to have 1 rotation. So I have 2 rotations over 2 pi, so I should have 4 solutions of that equation on the domain from 0 to 2 pi. All right, let's look at a half angle. So again, I'm going to do the same thing where I say, okay, let's let theta equal pi over 2. Okay, so if I solve this for 2 sine of theta minus root 2 equals 0, I'm going to add root 2 and then divide by 2. All right, well, let's think about all the places where sine is going to be positive root 2 over 2. Well, that's going to be at pi over 4 and 3 pi over 4. So that's what theta is equal to. And let's go ahead and just write that. And I know it goes on and on and on forever and ever and ever, every 2 pi. And then let's just make sure that all of these kind of fall within our restricted domain. All right, well, this is now equal to pi. Sorry, not pi over 2. This should be equal to x over 2. Goodness, x over 2. So now I'm going to multiply through to solve this for x. So that means that x is equal to pi over 2. 2 pi over 4 would be pi over 2 plus 4 pi n. Well, I don't have to worry about anything else being on my domain here. And again, if I multiply over here, x is equal to 3 pi over 2 plus 4 pi n. Well, I don't have to worry about that either. So this one just has these two solutions for x. All right, one more. We have alpha minus pi over 2 on the inside, so I'm going to let that be equal to theta, and then solve this for theta. So where is tangent of theta equal to 1? Well, that is going to happen whenever I have a triangle where the side lengths are the same. So that's at pi over 4 and 5 pi over 4. And then again, it happens every pi over 2 rotations. Or not pi over 2, sorry, 2 pi n rotations. And then I want to think about what happens when I have that negative pi over 2. So I'm going to add pi over 2 here. So when I add pi over 2, I'm going to get that alpha equals pi over 4 plus pi over 2, and then I'm just adding, so adding another 2 pi n. This is going to be 2 pi over 4, so I get 3 pi over 4. And if I keep adding another 2 pi, that's not going to be on my domain, so I just have that 1. And 5 pi over 4 plus, again, we'll do 2 pi over 4. And then I'm just adding another 2 pi over n. That gives us to 7 pi over 4 down here and here. And if you think about it, it is that switch, right? It's moving your tangent equation like to the right by pi over 2. So if you wanted to think about this rectangularly, normally you would have vertical asymptotes at negative pi and 2 over pi over 2, and your origin would be at 0, 0. This says move to the right by pi over 2. And so that's now going to be at pi and 0. And I would have another iteration here. And I want those to be equal to 1. So that makes sense that these are our two solutions.